rather awkward trig equation here. We're asked to show that it can instead be written as a hidden quadratic in terms of tan. So the first thing I'm going to do is expand it to give me 7 sine squared theta minus 4 sine theta cos theta equals 4. I can't really avoid it at this point. To get a tan, we need to divide through by cos because tan is identical to sine over cos. With arguments involved, tan x is sine x over cos x. So what I'm going to do is divide each term by cos squared. I'm just going to get 4 over cos squared, which is pretty awkward. In fact, you'll learn how to deal with this a little bit more in second year. But for now, let's just still go with it. So if tan is sine over cos, sine squared over cos squared is tan squared. 7 tan squared theta. And then the cos squared over here, that cos cancels with that squared. We're going to get 4 tan theta. So I've got that bit sorted. And that's equal to 4 over cos squared theta. Now what I'm going to do is use another identity. That 4 over cos squared is a bit awkward, but I do know that sine squared x plus cos squared x is identical to 1. So I can replace 4 by 4 sine squared theta plus 4 cos squared theta. And in fact, I'm then going to separate the fraction. It becomes this. Okay, so I just took the 4, wrote it as 4 sine squared theta plus 4 cos squared theta, separated the two fractions. This cancels out, so I'm back to having my 4. In a minute, I'll minus it. And then I've also got a 4 tan squared. Okay, that is, I think, the trickiest part of this question. But from this, we get our answer. We minus the 4 tan squared to give us 3 tan squared theta, and it's minus 4 tan theta minus 4 equals 0 as required. And to solve this original equation, well, in fact, we're going to use the hidden quadratic and factorize in terms of tan. So I'll get 3 tan theta and tan theta. That gets me the 3 tan squared. Then I want a minus 4 tan theta. So if I make this minus 2, I get minus 6 tan theta, and then plus 2, that'll give me the minus 4 tan theta, and I'll get the minus 4. So tan theta equals minus 2/3 or 2. Of course, you could alternatively just let u equal tan theta and put it into your quadratic solver. It would also give you minus 2/3 or 2. Just remember to get it back in terms of tan. Also, I've just remembered we're now using x. So I just need to change these to x's, sorry. Okay, so now I can do inverse tan of minus 2/3. We're solving between 0 and 3/60. We'll draw the tan graph. Look like that. So I'm going to get 2 solutions for minus 2/3. Let's do it. So I get minus 33.6. Actually, it gives me so when you do inverse tan, it always gives you the smallest, the angle closest to 0. So I'm not even going to write that one down. You can if you want. But if I add 180, because tan is periodic at about 180, I'll actually get my first proper solution, 146.309. And then for my second one, I'll add 180 on again. 326.30. By the way, if you're in any doubt with your solutions, you can always find like tan of them and check that you get back to what you should. I think people use this enough if they're having trouble with trig. get minus 2/3. I know it must be correct. And then I'm going to do the same with 2. That's going to give me these two solutions up here. Yeah, I'm just going to use my handheld calculator, but it's the same idea. So I get 63.434, or add on 180, 243.434. If you're using cast diagrams, I just mentioned them briefly. All sausages turn cold. We've got a solution here and then one here. The tan is the nicest one because you get this and then you just add on 180 to it to get that one, and you can just keep going if you need to. For the negative one, you'd get one hit here, and then yeah, you'd end up getting that anyway. So giving our answers to one decimal place, let's just write these down. X equals let's write them in order. So 63.4, 146.3, 243.4, 326.3. Hence, find the smallest solution of this equation. Now, it's only 1 mark. That doesn't mean it's going to be simple. Sometimes you have to work quite hard for a single mark. Note it's essentially the same equation, but I've replaced x by 4 alpha. So 4 alpha is going to equal all of these and more. And the range for 4 alpha is going to be, well, we need to take the 720 and times that by 4. So 2880. And we're looking for the smallest solution. So I'm not even going to worry about writing down the 1080. I just want the smallest solution beyond 2880. So really, I've just got to keep adding on 180 to my, like, I had this one and this one. Or in fact, I might as well start with these two. So if I take the 326, I mean, you can do it even quicker. You can go 326.3 and just add on like quite a large amount. We can add on 10 times 180, so 1,800. So that gets me to 2,126. So I'm just going to keep adding on 180 there. 2486, I get 26. Okay, that's still too small. If I keep going, I've got 2846.3. Okay, that is still too small. But I'll get 3026.3. That is going to be the smallest solution for 4 alpha. I'm then going to divide by 4 in a minute if it is indeed the smallest. But let's take the other one because I reckon this one's going to be a winner. 243.434. Add on again 10 lots of 180 because that will be a solution. Just keep adding it on. So I thought myself 2,763. Right, the next one is going to take me over to 2943.434. Okay, are there quicker ways to do this? I think this is a pretty safe way, I've got to say. I suppose you could work out how many, yeah, you could work out how many 180s go into 2880. That's going to be better. 16 of them, and then just add on 16 lots of 180 from the very beginning, or maybe 15 of them. That is a bit quicker. So then let's take the 2000, that's the 2,943.434 is the smallest. That is my 4 alpha. That means the smallest solution for alpha is going to be that divided by 4, which gives me 735.8585, so 735.9. Okay, a bit awkward. I do see questions like this quite often on Edexcel, so just be ready for it, take it steady, and we get there.